All right, welcome back. We are still in Unit 6, Plane Geometry. Today we're going to talk about general properties of triangles. All right, a triangle is a three-sided polygon. This would be labeled triangle A, B, C. You could call it ACB, you could call it BAC, you can call it BCA. Three coordinates name a triangle. Okay, the sum of the angles in a triangle is 180, which means this angle, angle A, plus angle B, plus angle C. If I add these up, they have to add up to 180. No more, no less. Another triangle fact that's important is the sum of the lengths of any two sides of a triangle has to be greater than the length of the third side. Also, more precise, I guess, is the two shorter sides have to add up to more than, not or equal to, more than the longest side, or you cannot form a triangle with those lengths. And the third fact is if two sides of a triangle are congruent, then the angles opposite those sides are congruent. So if I give you a triangle and I tell you that this side is equal to this side, then you know that this angle has to be equivalent to that angle. Okay? So let's talk about some different types of triangles. We have an equilateral triangle, and it has three congruent angles, which means that each angle, if it's an equilateral, it's no choice. All angles have to be 60 degrees because they have to be equal and they have to add up to 180. And the sides have to be congruent. So if this was 10, this has to be 10, and this has to be 10. An isosceles triangle has two congruent angles called the base angles. So this is called a base angle, and this is called a base angle, and two congruent sides. The third angle is called the vertex angle. So this one up here would be called my vertex angle. And the third side is called the base. So these are the two congruent sides, and this would be called the base. And like I said, in isosceles, when two sides are equal, then the base angles have to be, and vice versa. A scalene triangle has all different size angles and all different length sides. So none of the angles can be the same. None of these sides can be the same measure. If everything's different, then you have a scalene triangle. A right triangle has can't have more than one right angle in it. An acute triangle has all three angles that are less than 90 degrees. An obtuse triangle has can't have more, but has one angle that is greater than 90 degrees. Okay? Alright, so you answer this one, hit pause, come back when you're ready. Oops, sorry, too fast. Oh, there we go. Okay, which of the following statements about triangles is true? The sum of the measures of angles of a triangle is greater than or equal to 180. No, it has to be just equal to 180, so that's false. B, it is possible to have the sum of the lengths of two sides of a triangle be equal. No, that's false. It has to be more than the length of the third side. C, triangles always have an angle whose measure is greater than or equal to 90 degrees. False. Only obtuse triangles do. D, a triangle can have more than one right angle. Again, false. If you had two right angles, you ain't going to have a triangle. Because to get two right angles, I don't care how you draw it, that ain't going to make a triangle. That's going to make a quadrilateral. I don't care how you draw it, but it isn't going to make a triangle. Okay, the three angles of a triangle have to add up to 180. Well, if two of them already take up the 180, the third angle doesn't exist, there's not a triangle. E, it says if a triangle has two sides of equal length, then it must have two angles of equal measure. That's true. That's a theorem. It's been proven. It's called an isosceles triangle. Okay, so they want us to indicate whether each triangle is equilateral, isosceles, or scalene. You can tell by the little marks that they put on them. If I have a triangle that doesn't have like this is equal to this or 2 is equal to, then none of the sides are equal. That makes this scalene. Two sides are equal, which means two base angles are equal. That's isosceles. Which I can't spell. isosceles. And when you have all three sides equal, that makes equilateral. Okay, 2, indicate whether each triangle is right, acute, or obtuse. All 3 angles are less than 90 degrees. That's a cute little triangle. Okay, there's one right angle, so that makes this a right triangle. This has one obtuse angle, that makes this an obtuse triangle. Okay. 3, what is the measure of each angle in an equilateral triangle? Equilateral means all 3 angles are equal, and so I can call them all x, which says that 3x has to equal 180, because x plus x plus x is 3x, and the 3 angles have to add up to 180. Divide by 3. Each angle has to be 60 degrees. 4, one base angle in an isosceles triangle. Isosceles triangle has equal sides and equal base measures, and it says one base angle measures 50 degrees. What are the measures of the other angles? Well, if this is 50, this one has to be 50, and to get the third one, if I take 180 minus 50, that leaves 130, minus the second angle leaves 80 degrees. So my third angle has to be 80 degrees. 5, the vertex angle in an isosceles triangle is 50 degrees. What are the measures of the base angles? Well, if I take 180 degrees in all 3 angles and I subtract off the first angle, that leaves 130 degrees that I have to split in 2 because these base angles are equal. So that's going to give me 65 degrees for each of these. Okay, 6, if one angle of a scalene triangle measures 10 degrees, then what measure is impossible for either of the other 2 angles? In a scalene triangle, all 3 angles have to be different. So if this one is 10, I don't care what the other 2 are, but neither one of them, neither of the angles cannot equal 10 degrees, because the definition of scalene says that they all have to be different. So whatever the other angles are, they can't be 10 degrees. Okay, 7, what is the measure of angle A? Well, the 3 angles of a triangle have to add up to 180. So 80 plus 60 plus A has to equal 180 degrees. That's 140. Subtract that off, and you get A equals 40 degrees. Okay, and 8 says, are the measurements of this triangle realistic? If not, explain why. That's that one fact that says the 2 smaller sides of a triangle have to add up to more than the third side. Well, that gives me 5 is greater than 5, and that is false, so this is no, because I can't spell, because the 2 shorter sides have to add up to more than the third, or the longest. Okay, 9, what is the measure of angle A? Well, if this is, when 2 sides are equal, then the base angles have to be, so angle A is 45 degrees. Okay. Are the measurements of these triangles realistic? Explain. My 2 shorter sides would be 3 and 8. 3 plus 8 has to be greater than 12. That's only 11, which is not greater than 12, so this would be no, for the same reason as we said on the other one. Okay, on 11, my 2 shortest sides would be 10 and 11. So 10 plus 11 has to add up to more than 14, and it does. So yes, this would be a realistic triangle. Alright, you try this one, hit pause, come back when you're ready. And hopefully you got B. It says, which of the following statements cannot be concluded from the information presented in the figure shown below? Well, A says that the measure of angle B is 40 degrees. Well, again, this is isosceles. So if this is 70, this is 70. 70 and 70 is 140. 180, take away 140, leaves 40 degrees for angle B. That's true. It says the measure of angle C plus the measure of angle B. Well, the measure of angle C is 70. plus the measure of angle B is 40, which is 110 degrees. So that one is false. And you could check the others. AB is 12, which means BC is 12. So 12 plus 12 is 24. That's true. The measure of angle A is 70. That's true. And BC equals 12. That's true. Okay. Try this one. Hit pause. Come back when you're ready. And hopefully you got J. It says in the isosceles triangle below, which apparently I forgot to copy, but we can draw our own. It says AB, so if I do A, B, C, AB is equal to CB, which means these angles have to be equal. And it says, what's the measure of the vertex angle if measure of angle A is 40? Well, if A is 40, then C is 40. 40 and 40 is 80. 180 in the whole triangle, take away those two, leaves 100 degrees left over, which has to be angle B. Okay. Alright, hit pause. Come back when you're ready. And hopefully you got A. It says, which of the following choices could not be the lengths of the sides of a triangle? Well, again, if I take the two smaller sides, 3 plus 5 has to be greater than 9. 8 is not greater than 9. So, boom, right off the bat it fails. You can check the other ones. My two smaller sides, 6 plus 7 is 13, which is greater than 12. 2 plus 6 is 8, which is greater than 6. 12 plus 12 is 24, which is greater than 12. 5 plus 12 is 17, which is greater than 13. So the rest are true, but that one won't work. Okay, try this one. Hit pause. Come back when you're ready. And hopefully you got J. It says, which of the following statements is false? It says 40, 60, and 80 are the angle measures of some scalene triangle. Well, 40 plus 60 plus 80, that adds up to 180 degrees. That's true. That could be true. 60, 60, and 60 are the angle measures of some acute triangle. Well, they're all less than 90, and that adds up to 180, so that's true. 60, 60, 60 are the angle measures of an equilateral triangle. Well, equilateral means they're all the same, so that's true. 45, 45, and 90 are the angle measures of some obtuse triangles. That's false. Obtuse means greater than 90 degrees, not equal to. So that's true. That would be a right triangle, not an obtuse triangle. 45, 45, 90 of isosceles. Isosceles has to have two equal angles, and they do, so this would be true. So this is the only one that is false. Alright, try this one. Hit pause. Come back when you're ready. Come on. There it goes. Which of the following types of triangle always has at least two angles with equal measures? Scalene has no equal angles. Obtuse just means that one angle has to be bigger than 90. It doesn't mean that other two angles have to be equal. An equilateral triangle, yes, has all three angles equal, so that is at least two equal angles. A right triangle just means it has a 90-degree angle. It doesn't guarantee the other two are equivalent. And an acute triangle, that just means all angles are less than 90. That doesn't necessarily mean that any of them are equal. So it's got to be C. Alright, and we have finished our general properties of triangles. So I will see you next time.